Hello my dear students, welcome to the chemistry classes. In this class we are going to discuss about the continued part of the chapter D and F log elements. In the previous sessions of this chapter we have discussed about some of the concepts of D and F log elements. It means first classification of a periodic table. In the classification of periodic table we can classify the periodic table into four different blocks. First one is the S block elements, P block elements, D block elements and F block elements. Next, in this chapter, that is D block elements are nothing but these are the elements. These are the elements in which the outermost electron, that it means upcoming electron, will enter into the outermost valence or vacant d orbital. Hence, this type of elements are called as the D block elements. Like that, F block elements also, the outermost electron will enter into the valence F atomic orbital. Hence, these are called as the F block elements. Next, also we have discussed about the classification of the D block elements. This D block elements mainly classified into four different series of elements: 3D series of elements, 4D series of elements, 5D series and 6D series of elements. Like this, we have classified all the elements of the D block element into four series of the elements. Among those, we have discussed about especially about the 3D series of element. In the 3D series of element, totally 10 elements are there, from scandium to zinc, from atomic number 21 to atomic number 30. There are totally 10 elements are there in the 3D series. It means, and also we have discussed about the electronic configuration of the 3D series of element from scandium to zinc. And next, totally 10 elements are there in the 3D series of elements. It means 3D series of element, totally 10 elements are there. Totally 10 elements are there from scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper and zinc. Totally 10 elements are there in the 3D series of element from atomic number 21. From atomic number 21 totally up to 30. Totally 10 elements are there. Atomic number 21, atomic number 22, 23, 24, 25, 26, 27, 28, 29 and 30. Totally 10 elements are there. And in the previous session we have also discussed about the general properties or general trends of the 3D series of element. It means D block elements. In the 3D series of element, it means atomic radius and ionization enthalpy we have discussed. In the 3D series of element, the atomic radius going to change. It means, as we know generally, as we move from left to the right in the periodic table, there should be a gradual decrease in the atomic size. But in the 3D series of element, we can observe in the different case. It means from scandium to chromium, there will be a decrease in the atomic size. Next, from manganese to nickel, there will be a constancy in the atomic radius. Next, from copper to zinc, again there will be a increase in the atomic radius. This case happen in the 3D series of element. And also we have discussed this is due to the two important effect, that is called as the effective nuclear charge and Z effect ಅಂತ ಕರಿತೀವಿ ಅದಕ್ಕೆ. There are totally two. It is mainly due to the two important factors. And next, also we have discussed about the another property, general property, that is called as the ionization enthalpy. And next, in this class we are going to discuss about the continued part of the general properties and third property, general properties or general trends. General properties or general trends. First one we have studied atomic radius. Second one ionization. enthalpy. Second one, ionization enthalpy, and third one, oxidation state. Oxidation state of 3D series of element. In the previous class, we have discussed these two, atomic radius and ionization enthalpy, and in this class, we are going to discuss about the oxidation state for the 3D series of element. In the 3D series of element, what will happen to the oxidation state? It means the 3D series of element will show the variable oxidation states. It will show the variable oxidation states. It means the 3D series of element, it means scandium, titanium, vanadium up to zinc. These can show the variable oxidation state. It means, see here, what are the variable oxidation states in the scandium to zinc. Scandium will show the +2 and +3. The scandium will show the two different oxidation states. It means oxidation or that is ionization, nothing but it means that by the removal of electron or by getting the electron, it will attain the charge like this. Either there may be a positive charge or there may be a negative charge. If it gains the electron, if this scandium will gains the electron, it can be converted into scandium minus. Right? It means that is it will gain the negative charge. If the scandium will lose the electron, it will form the scandium plus. It means that is a losing of electron, or it means by losing electron or by gaining electron, it will get the charge like this. Either if it takes the electron, it will get the negative charge. If it loses the electron, it will get the negative charge. Like this, the scandium will show the two different oxidation states, +2 and +3. And next, in the titanium, it will show three oxidation states, +2, +3 and +4. It will show three different oxidation states, +2, +3 and +4. And next, vanadium will show +2, +3, +4 and +5. 4 oxidation states it will show. It means vanadium will show the 4 oxidation states. Next, chromium will show the +1, +2, +3, +4, +5 and +6. Chromium will show these different oxidation states, +1 to +6. There are variable oxidation states can be observed by the chromium metal. And next, this manganese metal will show the +2, +3, +4, +5, +6 and +7. It will show this type of different oxidation states. It means +2, +3, +4, +5, +6 and +7. And next, iron will show the +2, +3, +4, +5 and +6. Already you know Fe+3, Fe+2, Fe+4, Fe+5, Fe+6, like this it will show the different oxidation states. And next, copper will show the +2, +3 and +4. Like this it will show the variable oxidation states. And next, nickel, this also will show the +2, +3 and +4. Nickel also will show the different oxidation states. And next, copper will show the +1 and +2, but this will show the +2 oxidation states. These are the variable oxidation states which we can found in the different metals in the 3D series elements. These are the different oxidation states which we can observe in the 3D series of elements. Scandium will show the +2 and +3 oxidation state. Titanium will show the +2 to +4. Vanadium will show the +2 to +5. Chromium +2 to plus 6. Like this, these are the different oxidation state observed by the elements in the 3D series of elements. This can be observed due to the different facts. These variable oxidation states observed because of due to some reasons. What are the reasons? It means first reason, NS and there is a small energy difference. There is a small energy difference. Difference between NS and N-1 D atomic orbitals. This is the first reason. It means small energy difference between the NS and N-1 D atomic orbital. Due to the small energy difference between the NS and N-1 D atomic orbital, this will show the different oxidation states. And next one, involvement of both NS and N-1 D orbitals in bonding. During chemical bond, both N-1 and NS atomic orbital will involve in the bonding. Hence, this will show the different atomic orbital. And next, another one, to attain the stability, outermost electron electrons will be loosened by the element. It means while formation of the chemical bond, there may be a outermost electron will loosen very rapidly. It means to attain the chemical bond, to make the strong chemical bond, the outermost electron will loosen by the element to form a molecule like any molecule, FeCl3 or FeCl2. Like this, there will be a different molecules will be found. Due to these reasons, the 3D series of elements will show the different oxidation or variable oxidation states. Next concept. These are the reasons for the observing the different variable oxidation states in the 3D series of elements. And next concept is the standard electrode potential. Next general property is the standard. Fourth one, standard electrode potential. This standard electrode potential mainly depends upon the stability of element. This standard electrode potential mainly depends upon the stability of the element. The element which we are going to study, that based upon that element, this standard electrode potential mainly dependent. It means the stability of the oxidation state. Stability of the not element, this is oxidation state. This is oxidation state. The stability of the oxidation state. The stability of oxidation state mainly dependent on the electrode potential of the element. Electrode potential, the stability is inversely proportional to the oxidation state or standard potential. It means whenever the stability is going to increase, oxidation state going to decrease. Whenever the oxidation state is more, at that time stability, it means our standard reduction potential is standard reduction electrode potential. It means it is not oxidation state, this is electrode potential. Electrode potential. It means all the elements of 3D series of element, these are having the higher oxidation state. It means highly stable whenever the electrode potential is less. Electrode potential when it becomes less whenever the stability is more. It means all the elements of these elements of 3D series of element, it means scandium to zinc, these are having the lesser electrode potential due to the more stability. It means if the elements are less stable, the electrode potential is more, or if the elements are more stable, electrode potential is less, except copper. Except this element, all the elements are less stable due to the higher electrode potential. All the elements of 3D series of element, these are less stable due to the higher electrode potential, except copper, because this copper does not have the tendency. This copper does not have the tendency to give H2 or hydrogen gas. Does not have the tendency to liberate the hydrogen gas whenever reacts with a dilute acid. Whenever it reacts with a dilute acid, it does not have the tendency to liberate the hydrogen gas. Hence, this copper have the more stability and lesser electrode potential. This is the concept. And observe here the metallic property. Whenever reacts with the dilute acid nothing but these are the substance which can donate the H plus ion. These are called as the acids. It means whenever the metal reacts with the dilute acids, it can be converted into metal ion by the liberating the hydrogen. This property does not exhibited by the copper. Hence, except copper, all the elements are less stable as compared to the copper. This is the electrode potential concept, which we can observe in the 3D series of elements. And next property is the magnetic property. Next property is magnetic property. Magnetic property. Next most important property, that is called as the magnetic property. Already we know the majority of the D series of elements, it means as we move from left to the right in the periodic table, the metallic property going to decrease. It means as we move from top to the bottom, metallic property increases. As we move from left to the right, the metallic property going to decrease. It means already we know that majority of the 3D series of element or D block elements are metallic in nature. 3D series of element or D block elements are metallic in nature. In the metallic nature, we can observe the different types of metallic property, that is paramagnetic in nature, paramagnetic, diamagnetic, ferro, magnetic. Like this property we can observe in the solids, especially in the metallic solids. In the metallic solids we can observe the different types of metallic property. First one is the paramagnetic property, diamagnetic property, another one is the ferromagnetic property. Like these properties we can observe in the D series of elements, especially in the metallic elements. In this metallic elements, this is paramagnetic property is due to the presence of unpaired electrons. Presence of unpaired electrons in the outermost shell or valence shell. And if there is no presence of, if there is no unpaired electrons in the outermost shell or valence shell, it is called as the diamagnetic property. If the metals are having the unpaired electrons in the outermost shell, these are called as the paramagnetic. And if the metals does not having the unpaired electrons in the outermost shell or valence shell, these are called as the diamagnetic elements. And the elements which are having the more magnetic property, those are called as magnetic moment, those are called as the ferromagnetic substances. But this ferromagnetism we can calculate by using the formula that is called as the mu, that is magnetic property. This magnetic property can be calculated by using formula square root mu is equal to square root of n into n plus 2. Square root of n into n plus 2. By using this formula, we can calculate the magnetism or magnetic property of an element. In the 3D series of element, we can calculate the total magnetic property of the elements by using this formula, where n indicates the number of unpaired electrons. Number of unpaired electrons in the valence shell. It should be very important. Number of unpaired electrons in the valence shell, that can be indicated by the symbol n. N indicates the number of unpaired electrons in the valence shell. And next, this magnetic moment can be calculated in the form of Bohr magneton. This is the unit of the magnetic moment. This is the unit of magnetic moment. This is Bohr magneton. This is called as Bohr magneton. By using this unit, we can calculate the magnetic moment of an element in the D series of metallic series. Next, we can calculate the some magnetic moment for the some of the elements. First example, nickel. Nickel plus 2. Already we know the atomic number of nickel is 28. First, write the atomic number 28. In the examination, they may ask for to calculate the magnetic moment of nickel for the 2 marks. This is the 2 marks question. For the 2 marks, they can be asked this one. It means calculate the magnetic moment of Ni plus 2. Then first you should write the initial electronic configuration of nickel. Nickel is having the atomic number 28. Nickel having the atomic number 28. It means it is having the electronic configuration argon. Up to argon, this is the complete electronic configuration. Next, after the argon, there is a 3D and 4s. 3D and 4s. This is the electronic configuration. Next, 3D8, 4s2 is the total electronic configuration of the nickel. This is the total electronic configuration of nickel. Next, if the nickel undergo excitation, excitation means it is undergo ionization. While after ionization, it will loses 2 electrons. Plus 2 means it is losing 2 electrons. Then outermost electrons, these 4s2 electrons are less stable. These 2 electrons are undergo losing. Next, at that time, whenever nickel undergo plus 2, at that time atomic number going to change, that is 26. Number of electrons going to change, that is 26. Next, electronic configuration becomes AR. Up to AR, this is complete electronic configuration. Next, 3D8, 4s2 is the electronic configuration of the Ni plus 3D8, 4s0 is the electronic configuration of the Ni plus 2, nickel plus 2. Allot the electrons here. I will write here. Allot the electrons. 3D electrons. According to Ohm's rule, we should allot the electrons like this. First unpaired, afterwards they are pairing. Totally 8 electrons. Next, 4s. Total 2 electrons are there. This is the electronic configuration of nickel in the ground state. In the excited state, it loses the 2 electrons. 2 electrons are from outermost shell. 3D8, 4s0. This is the outermost shell valence electronic configuration. Next, allot the electrons here. According to Ohm's rule, the electrons are first filled by unpaired. Next, they are pairing. Next, 4s atomic orbital is completely vacant because the electrons from 4s atomic orbital they undergo ionization and they loosen. It means 4s atomic orbital completely 0. Next, observe here in the nickel, the outermost shell having the totally how many valence electron? Totally 2 valence unpaired electron. Totally 8 valence electrons are there. Among those 8 valence electron, 2 electrons are unpaired here. Right? 2 electrons are unpaired. First write the formula here. Mu is equal to n into n plus 2 Bm. This is the formula. In this formula, now we are calculating the magnetic moment. We are calculating the magnetic moment here. N, what is the value of n? N is equal to 2 because 2 unpaired electrons are present in the outermost shell. Then we should take the value of n is equal to 2. Then substitute the value of n is equal to 2 in the above equation. We will get the mu is equal to square root of 2 into 2 plus 2 is equal to square root of 2 into 4 is equal to 2 root 2 is equal to 2 root 2. This is Bm अथवा 2.84 Bm. This is the total value. It means magnetic moment of Ni plus 2 ion. At the final, you should write here. Therefore, magnetic Ni plus 2 ion. Magnetic moment of Ni plus 2 ion, Ni plus 2 is 2.84 Bm. At the final, you should write the Bm. Bm means that is the Bohr magneton. It is the unit. At the final, you need to write the unit. That is the 2.84 Bm. Bohr magneton is the unit magnetic moment of the Ni plus 2 ion. This is the one example. And second example. Second example. Fe plus 3. Fe plus 3. What is the atomic number of Fe? That is 26. Write that first. Fe 26 is the atomic number and its electronic configuration Ar 3D and 4s. 3D and 4s. 4s2 next 3D. It is 3D5, 3D6, 4s2 is the electronic configuration for the iron in the ground state. In the ground state electron, this is the ground state electronic configuration of iron. Write the allot the electrons. Next 6 electron, next 4s2 atomic orbital here. Like this is the electronic configuration of the iron in the ground state. Next, if the iron undergo oxidation like Fe plus 3, at that time 3 electrons will going to change. At that time the atomic number becomes 23. Next, electronic configuration Ar 3D5 4s0 is the electronic configuration in the excited state. Next, allot the electrons. It means totally 5 electrons are there in the valence shell. 5 electrons are there in the valence shell. Next, here the value of n becomes 5 because there are 5 unpaired electrons in the valence shell. They ask for Fe plus 3, not Fe. They are asked for Fe plus 3. Fe plus 3 means it is undergo excitation and it will lose the 3 electrons. At that time electronic configuration becomes like this: 3d5 4s0. In the outermost shell there are 5 unpaired electrons are there. We should take the value of n is equal to 5, then substitute the value of 5 in the above equation. Write the equation. Mu is equal to square root of n into n plus 2. Mu is equal to 5 into 5 plus 2. Mu is equal to 5 square root of 5 into 5 plus 2, 5 into 7. 35. Square root of 35 is equal to 5.96 Bohr magneton is the magnetic moment of the Fe plus 3 ion. Magnetic moment of Fe plus 3 ion is 5.96 Bohr magneton. Next, write the answer here. The magnetic moment of Fe plus 3 ion is 5.96 Bohr magneton. Magnetic moment of Fe plus 3 is 5.96 Bohr magnetron. This is the answer. At the final, you should write this one. Magnetic moment of Fe plus 3 ion is 5.96 Bohr magnetron. Next, third example. Third example. Third example. Next, take Ti plus 4. They ask for Ti plus 4. Already we know the atomic number, ground state atomic number of titanium is 22. Ti 22 is the electronic configuration for the titanium. Next, write the electronic configuration up to A. This is the complete electronic configuration. Next, 3d to 4s2 is the complete electronic configuration for the complete electronic configuration for the 3d, that is titanium ion. Next, allot the electrons here. Next, this is the ground state electronic configuration of titanium. Totally 2 electrons in the 3d atomic orbital and 2 electrons in the 4s atomic orbital. Totally there are 4 electrons in the outermost shell. Next, whenever this titanium undergo oxidation, it means whenever it loses the electron, it is undergo Ti plus 4. Whenever Ti plus 4 is undergo, then atomic number going to change, that is 18. 18 is the electronic configuration, that is completely filled atomic electronic configuration, that is stable electronic configuration. At that time, in the valence in the ground state, there are totally 4 electrons in the outermost shell. These 4 electrons are undergo ionization. Totally at that time there will be a 0. It means there is no electrons in the outermost shell. At the Ti plus 4 stage, it means titanium undergo oxidation. At that time there is no electrons in the outermost shell. It means there is completely 0 electrons in the valence shell. Then number of the value of n is equal to 0. It means the number of valence electrons means 0. Then n is equal to 0. Substitute this value in the above equation. Mu is equal to n into n plus 2. Mu is equal to 0 into 0 plus 2. Right? Mu is equal to 0 into 0 plus 2. Mu is equal to 0. Right? 0 plus 2 means 0 into 2. Total is 0. Square root of 0 itself is 0. At the Bohr magneton, the magnetic moment of Ti plus 4 is, the magnetic moment of titanium plus 4 is completely 0. 0 Bohr magneton. These are the some examples for the magnetic moment. Here we have observed the totally nickel plus 2, Fe plus 3 and Ti plus 4. We have calculated the 3 magnetic moment for the 3 elements. Nickel 2.84, 5.96. This is completely 0. Among these 3 elements, Ti plus 4 is completely 0, Ni plus 2 2.84, Fe plus 3 is 5.96. It means the elements by the conclusion, by this fact, by this concept, we can conclude that the elements which are having the more magnetic moment, these are ferromagnetic in nature, and the elements which are having the lesser magnetic moment, these are anti-ferromagnetic in nature. This is the concept. It means elements which are having magnetic moment are ferromagnetic in nature. This is the conclusion drawn from the magnetic property of the metals of the 3D series of elements. This is the conclusion drawn from these elements. This is about the magnetic property or magnetic moment of 3D series of elements. In the next class, we are going to discuss about the next continued part of this 3D series of elements. Thank you.